when considering the factorisation of a quadratic such as this one. The trick is initially to consider the product made by the 3 and the negative 14 at the two ends of the quadratic. These two multiply together, 3 times negative 14, to make negative 42. So we need to find a different pair of numbers that also have a product of negative 42, or we could consider the pair of numbers that need to have a sum of plus 19, which comes from here, the middle term. The pair of numbers that we need must satisfy both of these requirements, so the product is negative 42 and the sum is positive 19. So let's consider some possibilities that have a product of negative 42. They could be negative 42 and positive 1, but they add to negative 41. Positive 42 and negative 1 add to positive 41. Negative 21 and positive 2, they add to negative 19, or positive 21 and negative 2, they add to positive 19, so this is the pair that we are looking for. We could have considered numbers that have a sum of plus 19. Now interestingly, because we have a negative 14, we know that the signs of these two numbers are different, so that reduces our options. So if they have a sum of plus 19, the larger one must be positive, so perhaps we could try positive 20 and negative 1, but they multiply to negative 20, or positive 21 and negative 2, and they multiply to negative 42, so that is the pair we're looking for. If you look carefully, you'll see that it's the same pair of numbers. So you could find this pair of numbers by either considering the products or considering the sums. Either is acceptable, but sometimes it's quicker using the products and sometimes the sums. In this case it only required us to check 2 pairs for the sums but 4 pairs for the products before we had found the pair we were looking for. So now we have found the pair that we were searching for, positive 21 and negative 2, we need to split the centre term into 2 parts. Usually it's helpful to select the negative first, so I'm going to change this plus 19x into negative 2x plus 21x. So now my quadratic has 2 pairs. It has the first pair and the second pair, which we are going to factorise in turn. The common factor of the first pair here is x. So if I remove that from this first pair, it leaves me with 3x minus 2 multiplying by the x. And in the second pair here, the common factor is 7, but it helps to put the sign in front of it. That's positive 7. The factor that remains then is 3x minus 2, and a check for us is that these two factors are the same. Now I need to factorise again, and I can see that 3x minus 2 is common to both of these two expressions, and the factor that goes with 3x minus 2, well, from the first pair here we had an x, and from the second pair here we had a plus 7, which was why it was useful earlier to put the sign in front of the 7. We now find that we have completed our factorisation, so we can underline our final factorisation. So, to recap briefly, the factorisation of 3x squared plus 19x minus 14 is 3x minus 2 multiplied by x plus 7. And we could check this by expanding the brackets. 3x times x gives me 3x squared. 3x times plus 7 gives me 21x. Negative 2 times x gives me negative 2x. And negative 2 times plus 7 gives me negative 14. And collecting the like terms in the middle, this gives me 3x squared plus 19x minus 14. So we know that our factorisation is correct.